Hello everyone, I am Professor Awais Ahmed Hussaini, working as Assistant Professor in Mechanical Engineering Department at Sharad Institute of Technology, College of Engineering, Yadrao. So students, in this video we will discuss a chapter Steam Turbine. In that we will discuss introduction of the impulse turbine. So let us start with the working of the steam power plant in brief. So the basic component of the steam power plant is boiler. In boiler the steam is created at high pressure. The next important component in case of the steam power plant is a steam turbine, where the steam is expand and its pressure and temperature goes on decreases, and outcome in terms of the mechanical energy. Next important component is generator, where that mechanical energy get converted into electricity. And the next important component is condenser, along with that cooling tower, where the phase change of that steam from the vapor to liquid state, and n number of the auxiliary equipments like pumps are used. Also there is one important component, that is cooling tower in case of the steam power plant. So the most important thing in case of the steam power plant as far as that energy generation is that steam turbine. So a steam turbine is a prime mover in which the potential energy of the steam is transferred into kinetic energy, and that kinetic energy later on is converted into mechanical energy in terms of the shaft rotation. So students, this is the main function of the steam turbine. The main function of the steam turbine is to convert that kinetic energy of the steam into mechanical energy in terms of the shaft rotation. So the steam turbine classification, the steam turbine is classified according to so many types. The first is according to the flow direction. The steam turbine are classified into axial, radial flow, tangential flow and mixed flow. According to the working principle, that is energy conservation, the steam turbine are classified into mainly two types. The first is impulse turbine. The best example of the impulse turbine is D-level turbine. The second one is reaction turbine. The best example of the reaction turbine is Parsons reaction turbine. The third important way of the classification of the steam turbine is types of compounding. So students, compounding is a method of reducing the shaft speed. So here there are three types. The first is pressure compounding, second one is velocity compounding, and third one is the combination of pressure and velocity compounding. The next type of the classification according to the exhausting condition, the first is condensing type, extraction type, back pressure type, and fourth one is reheating type. Also according to the number of the stages, there are two types. The first is single stage and second one is multi-stage. According to the pressure available at the inlet, there are three types: low pressure turbine, medium pressure turbine, high pressure turbine. In case of the low pressure turbine, the pressure is up to 2 bar. In medium, the pressure is in between 2 bar to 40 bar, and in case of the high capacity turbine, the pressure is more than 40 bar. So these are the advantages of the steam turbine over steam engine. So students, steam engine is also one kind of the prime mover, but how it is differ from the steam turbine, here we will discuss. So these are the advantages of the steam turbine over steam engine. The first advantage is that thermal efficiency is much higher. Second one is, as there is no reciprocating parts, perfect balancing is possible in case of the steam turbine. We know that in case of the steam engine, a lot of the parts is there, and because of that a number of the problem is there, like frictions, noise. So it can be minimized in case of the steam turbine. The third one is a high and greater range of the speed is possible in case of the steam turbine rather than steam engine. The fourth is the lubrication is very simple, as there is no rubbing parts, less moving parts, so less friction is there. Fifth one is the power generation is at uniform rate, and hence no flywheel is required for energy storage, but that flywheel is required for storage of the energy in case of the steam engine. The steam consumption rate is less, more compact, and require less attention during the operation, more suitable for large power plant, less maintenance cost, considerable overload can be carried to expense of the slight reduction in the overall efficiency. So these are the advantages of the steam turbine over steam engine. So let us start. The first important thing of this particular lecture is working and construction of the impulse turbine. So students, as we know that the impulse turbine works on impulsive action. So this is the working principle of the impulse turbine. Basically parts of that impulse turbines are two. The first is nozzle and second one is that moving blade. The main function of the moving blade is to absorb the energy of the steam, and after rotation we will get the mechanical energy in terms of the shaft rotation. The blades of the steam turbine is mounted over the shaft. The main function of the steam nozzle is to expand that steam and convert that pressure energy into kinetic energy. So here you will get idea about the construction and working. So it is a primary consist of the nozzle as a set of the nozzle. So more than 7 or 8 nozzles are there, up to 26, 28 number of the nozzles are used generally in case of the steam power plant, but in case of the hydroelectrical power plant only one nozzle is used. So here you will get idea about the working. So whatever the steam is coming from the boiler at a high pressure, it enters on the surface of the nozzle. That nozzle may be convergent, it may be divergent, or it may be convergent and divergent type, combination of the both. When steam in high pressurized steam is come in contact with the nozzle, the pressure energy of that steam get converted into kinetic energy, that is velocity goes on increases. And when high velocity of the steam is strike on the surface of the blades, then that particular blades of the steam turbine absorb that energy and it gets start rotating, and at the end we will get the mechanical energy. So this is the construction and working of the steam turbine, and the blades of the steam turbine is mounted over the shaft. So here you will get idea about the components. This is a nozzle. Initially steam coming from the boiler is enters in the nozzle. So in nozzle here you will get the idea about the in terms of the graph changes. So here the velocity goes on increases when the steam is coming in contact with the nozzle. So here pressure energy get converted into kinetic energy. Simultaneously the pressure energy goes on reduces in the nozzle, and that pressure energy remains constant when that steam is come in contact with the blades. But here when the steam is come in contact with the nozzle first, then that pressure energy get converted into kinetic energy and velocity is increases, that is kinetic energy is increases, and that kinetic energy of the steam get absorbed by the blades. So here you will get idea about that kinetic energy, that is velocity goes on reduces when that steam is come in contact with the moving blades. So this is all about simple construction and working of the impulse turbine. So basically there are two types of the there are two components of the impulse turbine. The first is that steam nozzle and second one is that moving blade. So initially the high pressurized steam is come in contact with the steam nozzle, where that pressure energy get converted into kinetic energy, and when that high kinetic energy or high velocity steam is enters on the surface of the blades of the steam turbine, where it get absorb that energy and produce mechanical energy in terms of the shaft rotation. So here in impulse turbine, the steam coming out through the fixed nozzle. The nozzle is fixed, it is in static condition at a very high velocity and strike the blades fixed on the periphery of the rotor. That rotor is mounted over the shaft. The blade changes the direction of the steam flow without changing its pressure. The force due to change of the momentum cause the rotation of the turbine. So this is the main working principle, that is change of momentum of the impulse turbine, that is D-level turbine. These are some examples of the impulse turbine, that is D-level turbine, Curtis and Rative turbines. So this is again construction and working. We already discussed that particular parts. There are two parts of the impulse turbine. The first is steam nozzle. It may be convergent, divergent, or combination of the both. The main function of the nozzle is to produce kinetic energy of the steam by converting pressure energy into kinetic energy, and at the end of the nozzle we will get high velocity of the steam, and that high velocity of the steam is enters on the surface of the blade. So the blade is continuously rotating by absorbing that energy, and due to that we will get a mechanical energy in terms of the shaft rotation. So students, here you will get idea about the velocity diagram, that is velocity triangle. Here you will get the n number of the parameters. This is the blade, this is the moving blade of the impulse turbine. Here for consideration I take only one blade. So the main function of the blade is to absorb the kinetic energy of the steam, then it start rotating. So this is the inlet triangle, this is the outlet triangle. You can say it as the inlet velocity triangle. Here this is the outlet velocity triangle. So n number of the parameter you will get, n number of the variables like that. V1 is nothing but absolute velocity of the steam at inlet. Alpha 1, that is nozzle inlet angle. So here is the nozzle. The steam coming from the boiler is first enters on the surface of the nozzle, and from nozzle it strike on the surface of the blades by its relative velocity. So the U is nothing but that blade velocity in terms of the meter per second. VR1 is nothing but that relative velocity of the steam at inlet in meter per second. VW1 is that tangential velocity. It is also called as the whirling velocity of the steam at meter per second. This particular axial velocity VF1 or VA1, axial velocity of the steam at inlet. Beta 1 blade inlet angle, beta 2 blade outlet angle. So here there are total 4 angles, students. So here alpha 1 indicates nozzle inlet angle. You will get idea about that. And alpha 2 is that nozzle outlet angle. Beta 1 is related with that blade inlet angle, and beta 2 is related with that blade outlet angle. VR2 is the relative velocity of the steam at outlet. VW2, that is tangential velocity of the steam at outlet in terms of meter per second. VW2 is the whirling velocity. That U is nothing but the blade velocity, which is remains constant in all cases. The U is remains constant. You will get that U by formula pi d n by 60. So where d is the diameter of that wheel and n is the RPM, you will get that particular U in terms of meter per second at the end. K is a blade velocity coefficient. So whatever the steam is entering at the inlet condition, the same steam is not come out. So there is always some kind of the friction is there. If you want to neglect that friction, so we never consider the effect of the K. But if you want to consider the effect of the friction, you must have to consider the effect of the K. V2 is the absolute velocity of the steam at outlet in meter per second. So these are the n number of the parameters. I repeat once again. So whatever the steam is enters on the surface of the blade with that relative velocity, that is VR1, and the nozzle inlet angle is alpha 1, and steam moves out through that nozzle having that velocity alpha 2. Beta 1 is the blade inlet angle, beta 2 is the blade outlet angle. So that VW1 is the whirling velocity at inlet, VW2 is the whirling velocity at outlet. U is blade velocity, which is remains constant in case of the inlet and outlet velocity triangle. That is V1 and V2 are that absolute velocity at inlet and outlet. Similar way that VA1 and VA2 are the axial velocity at inlet as well as that axial velocity at outlet. So here, student, you will get idea about the combined velocity triangle. So this is a very easy method. We will discuss during the problem solving technique of that related with that impulse turbine. Here you will get idea about that how to draw that combined velocity triangle by make availability of the n number of the parameters like blade inlet angle, blade outlet angle, nozzle inlet angle, then absolute velocity and whirling velocity and all. So students, this particular lecture is related with the basic introduction of that working and construction of the impulse turbine. Afterwards we will discuss, after 2-3 lecture of the completion of that introductory part, we will solve the numerical, and there I will tell you how to draw that velocity triangle with the help of that pen, then some kind of the instruments like that compass and all. So this is the most interesting part we will discuss after completion of the 2-3 lectures related with the introduction and the theory. So here you will get idea about the work output, that is power of that is the blade efficiency and stage efficiency of the steam turbine. So students, the forces in the tangential direction is nothing but the rate of the change of the momentum in the tangential direction. So that particular word or line, the rate of change of momentum, is the working principle of the impulse turbine. So it can be denoted by the mass per second into change in the velocity. So this is the working principle of the impulse turbine, m into that v. So that here we will consider the whirling velocity, m is m into vw1 plus or minus vw2 in terms of the Newton or Newton meter. So while solving the numerical, we must have to use these all formulas. So before that we must have to draw the velocity triangle. On the basis of that velocity triangle, we will get the values of that vw1 and vw2. It is not directly given in the problem directly in the numericals. So we must have to find the value of the vw1 and vw2 through the actuals, by taking the actual scale with the help of putty and that some instruments used for that drawing. So this is a force in the axial direction. It is known as the axial thrust. The formula is rate of change of momentum in axial direction. So m into va1 minus va2, sometimes v1 minus v2 in terms of the Newton. In every book, in case of the Kurmi Gupta as well as in case of the R.K. Rajput, the designation are some changes. So here we can consider va1 minus va2, or you can take v1 minus v2. So work done is nothing but m. The work done is same as that of the force in the tangential direction. So m vw1 plus minus vw2 into u. So that u is nothing but that absolute velocity, or you can say it is it has a blade velocity. It is a absolute velocity, not a absolute, but it is a blade velocity, and that blade velocity is calculated by using the formula pi d n by 60. Here you will get idea about that particular work done. So the formula of the work done is most important while solving the numerical. So the formula is m in bracket vw1 plus minus vw2 into u, where m is the mass per second, vw1 is the whirling velocity at inlet, vw2 is the whirling velocity at outlet, and why plus and minus sign here? On the basis of velocity triangle, we can choose that sign of the plus and minus. If outlet velocity triangle is come inside that absolute velocity, then we will take that minus. If it is outside, then we will take the plus. So there is some basic logic and techniques is there. We will discuss at the time of the solving the numericals. And u is that blade velocity. If it is not given in the problem, then use the formula pi d n by 60. At that time in the problem, the value of the d and n are mentioned. So the power developed is m vw1 plus minus vw2 u upon 1000. If you want answer in kilowatt, so 1 Newton meter per second is nothing but 1 watt. Similar way, if you want to convert that watt into kilowatt, you just divide it by 1000. So this is the formula, is the blade efficiency, that is work done on the blade upon energy supplied to the blade. So students, through kinetic energy we will supply that energy to the blade. So the input energy of the steam turbine is through that nozzle, and it is a kinetic energy, and the formula of that kinetic energy is half mv square. So here I just mentioned v1 because this is the inlet term. So here work done is already available with us, this value is already with us. Then just I put the value of the energy supplied, that is kinetic energy. It happened in case of the steam nozzle, half mv square. By some mathematical arrangement we will get this. So I just shift that 2 on the numerator, and you will get the value 2u vw1 plus minus vw2 u upon v1 square. So that here the v1 is the absolute velocity at inlet. Now energy loss due to blade friction is calculated by using this formula, half m VR1 square minus VR2 square. This is relative velocity at inlet and this is relative velocity at outlet. VR1 stand for relative velocity at inlet and VR2 stand for relative velocity at outlet. And finally you will get the stage efficiency, that is work done on the blades on the total energy supplied per stage. So here we already have the formula of the work done, m VW1 plus minus VW2 in bracket U upon m H1 minus H2. So here that heat drop indicate that H1 minus H2, that is HD. You will get the formula of the stage efficiency. So stage efficiency is equal to VW1 plus minus VW2 into U upon HD. HD stand for the heat drop. You will get all values of that H through the steam table. So here in numerical, definitely we must have to calculate the work done, then power developed, blade efficiency, energy lost and stage efficiency. So thank you. So our next video is related with the reaction turbine. There we will discuss construction and working of that reaction turbine, and after that we will discuss compounding in next lecture, and after completion of the theory we will take examples. Thank you.